What's up, guys? I'm Ethan Teach here to talk to you about respiration. Now, this respiration is similar to cellular respiration that your know-it-all biology teacher taught you, but it is not the same. So what's different? Well, this is what we call external respiration, okay? And it is how you get the oxygen into your blood to begin with and get CO2 out later, but let's focus on oxygen, okay? So, why is it external when we know that the lungs are inside of our body? That is a great question. Here's why. The lungs are connected to a tube, okay, trachea, bronchial, larynx, pharynx, and through your mouth to the outside world. So, even though this is technically happening inside your body, it is all connected to the external environment. Therefore, it is the external respiration. Cellular respiration that your biology teachers taught you, that is actually a form of internal respiration, which means it's happening completely within the body. So let's talk about external respiration. It has a lot to do with how much pressure is inside our thoracic cavity. Now, we talked about atmospheric pressure being about 14.7 psi at sea level. So if I'm at sea level and I want to breathe out, what I'm going to have to do is I'm going to have to get the pressure inside of my thoracic cavity greater than 14.7 psi. How do we do that? Well, the main way we do that is using the diaphragm muscle. Okay, so the diaphragm muscle, when it is relaxed, it returns to an upward state. We know skeletal muscle cannot contract forcefully. Cannot relax forcefully. So when the diaphragm is up, it's at a rainbow shape, it is relaxed. When it is pulled down, it is contracting. Okay, so that's breathing out, breathing in. Relax, contract. Relax, contract. Relax, contract. Now, what's happening to the balloons in there, which represent our lungs? Well, when the diaphragm is relaxing and going up, they're getting smaller. And when the diaphragm is contracting and being pulled down, they are filling with air. Now, notice that the diaphragm never actually comes in contact with the balloons, yet they are still moving. And that's the same way in our body. The diaphragm doesn't need to contact the lungs to get them to move. So here's how this works. Let's start with inhaling. The fancy word for that is inspiration. So, with inspiration, it's very simple. All we have to do is get the pressure in the thoracic cavity, or the pleural space, below 14.7 psi. How do we do that? Well, we know pressure and volume are inversely related. So, we cannot directly affect the pressure, but we can increase the volume by increasing the amount of space in here. So, the diaphragm contracts and moves down, our volume goes up, which means our pressure must go down. So, let's take a look at that. Okay, so this is inhaling or inspiration. Diaphragm's contracting, and the balloons are filling with air. It's the exact same way that your lungs would work. So that's when the diaphragm is contracting or going down. Now, let's talk about expiration or exhaling. The way the body works for that is very simple. We need to get the pressure inside the thoracic cavity greater than atmospheric pressure, which at sea level is about 14.7 psi. So how are we going to do that? Well, the diaphragm cannot forcefully go up, but when it relaxes, it will return. When it relaxes, it will return to a rainbow shape, and it will actually make the thoracic cavity volume smaller. And if the volume goes down, we know the pressure has to go up. So let's take a look at that. So here's my diaphragm, fully contracted. Notice the balloons are full of air. And the diaphragm relaxes, and the balloons are losing air, and the body is exhaling or expiring. Okay, now there's a third option that the body can do. The diaphragm has no movement, like we see right now. We got no movement going on. What's happening? Are we breathing in or out? No, we're doing neither. And because this is a skeletal muscle, the diaphragm is, you cannot breathe at all. So if I simply stop talking, stop breathing, you have no net movement. Now, what does that mean? That means the third option. We're not inspiring, we're not expiring. We are simply not breathing. We have no net movement in the diaphragm. That means the pressure inside of our thoracic cavity is equal to the pressure outside of our thoracic cavity. Ethan Teach out.